Hello, everyone. Thanks for joining this morning. My name is Seth. I'm a product manager at Datarobot, and I'm joined by Chris Cozy, also a product manager here at Datarobot. And today we're going to show you MLOps in action. We'll run through Datarobot's view of machine learning operations, where we see trends in the industry. And we'll also show a quick demo of utilizing our architecture and framework to quickly get models into production and manage and monitor them in a production framework. So thanks for joining. We do have a couple slides just to set the groundwork before we jump into the demo, and some quick housekeeping rules before we get started. We encourage questions. If you do have any questions, throw them into the chat screen, and we'll prioritize them when we can throughout the session. But as things come up of interest or any questions come to mind, definitely encourage you to throw those into the chat. So just to set the stage on Datarobot's view of machine learning operations, here's a kind of an architecture diagram of our MLOps product. The highlighted areas in orange are going to denote areas that are within the Datarobot architecture, meaning components of our framework that we own. So Datarobot has a rich foundation in building models, what we call automated machine learning. We'll discuss quickly how that AutoML can be brought into an MLOps process to facilitate things like challenger modeling and retraining, core components of managing ML life cycles. We also have core areas of consumption of post-production output, right? What we call AI applications. So those are going to be, no-click frameworks to build applications that can consume one or more deployment outputs for the business, right? So much more accessible for different types of personas, business analysts, maybe less technical team members. So it's really a point of collaboration. And then the other areas, starting from left, we have, ML development framework. So we mentioned, AutoML and our kind of core competency in building models. Well, with Datarobot MLOps, we're also opening up the framework and foundation for any model, right? And it's very flexible and very scalable to meet different business needs, from any programming language, R, PMML, Java, SAS, Python, kind of you name it, you'll be able to support getting that model effectively into production in a repeatable and scalable way, and scaling that deployment once in production for general maintenance and management. We also support a variety of packages or libraries. It's at the user's discretion. So whether it's H2O models, scikit-learn, OWN and X, PyTorch, TensorFlow, whatever the framework is that you're relying on to meet your use case, your model, you can support that within this framework. So what that opens up is really any development environment that you're utilizing now, you can plug into this framework to get advantage of a scalable infrastructure to, one, get those models into production in a repeatable and scalable way, right? And then two, to have visibility into the performance and health of that model over time, right? And then that's where we're going to bring some of our advantage in doing this, in a very robust way over many years. We have made, billions of predictions with millions of models in production. So we've hardened our framework that we're utilizing now for any model, not just those that we've built, and opening that up to an ecosystem that our users can apply to their tech stack and their use cases. So what we're going to show you today is how you can get those models that you've developed in-house, trained in-house with your language of choice, using your libraries in your development environment. We'll show you how to get those models into production in a scalable and repeatable way. But there's another very robust process that MLOps provides, feature rather, and that's going to be shown on the lower horizontal graph. So deployment is an initial hurdle for many organizations, but many organizations have already figured out how to utilize their architecture and their resources to get models into production, right? And so with our agent-first approach, what we provide is a way to get benefit of Datarobot MLOps without having to move those models or redeploy those models. So we're providing an agent system to assess the quality of those models, essentially for monitoring, and channel that data back to Datarobot for performance monitoring, for lifecycle management, and for governance of those models and those deployments. So this provides even more flexibility to leverage both a deployment path for models that you may have in queue for deployment, but also get benefit for models that you've already invested in and might already be in a production sense. And it's quite agnostic to where that production could be. It could be on cloud architecture, it could be on local architecture, it can be models that Datarobot has made and built and exported. It can be models that you have made and built and exported and utilized, your cloud provider of choice for resource management. It could be on Kubernetes. A lot of flexibility, but the benefit that Datarobot is going to provide, again, is that streamlined process for monitoring those models and managing them in production framework. So with that, we'll jump over to the demo and we'll see MLOps in action. And again, encourage any questions as we touch on topics that are of particular interest. Great, so here is my deployment dashboard. These are models that have already been productionalized and are seeing prediction traffic, right? So at the top level, you get a overview of those deployments that are seeing live traffic. And what we provide are dimensions of stability from service health to data drift analysis and accuracy. And we surface those at a portfolio view here at the top to get a quick snapshot across your portfolio of models that are in production. Right, we'll come back to this view. What we want to focus on is first registering one of our models through our model registry, right? And testing that model before we place it into production, and then making predictions against that model. And we'll come back to this view to assess some of the more mature model monitoring dimensions of a model that's seen some production traffic for some time. So we'll start here with our model registry. This is going to be an entry point to adding a new model into the model registry. So the steps to do this are quite easy. The first thing that we'll do is name our model, and then we'll need to select our target type. And here you can see that we provide a lot of support for many different types of models, from binary to regression to multi-class to anomaly detection, unsupervised models, and a system that we call unstructured. And unstructured provides a lot of flexibility in the types of prediction responses that you can return with your model rather than to conform to a specific framework. But here, what we want to show is a regression model, and we'll provide our target variable, and then we'll add the custom model to our custom model workshop. So here we'll provide some nudges to getting this model configured for an initial test, and then deploy the model into production. The first step to testing the model is going to be selecting a base environment. So these are going to be essentially Docker containers that can host our model, right? And we provide a variety of, quote, drop-in environments that are pre-configured with a lot of common libraries and requirements that we see from our clients in the field. Today, I want to show a PyTorch model that we've trained for the event. So I'm going to select our PyTorch drop-in library. And then we're ready to start assembling our model. So this is where you can collect files using file management systems of your choice, local files, or you can select and pull from a configured remote repository, which in this case is what we're going to do. So here, Datarobot can pull from, repositories, from, S3 buckets, from GitHub Enterprises, from Bitbucket, a lot of choices here. In our case, I want to pull from my Datarobot user model open source library. I encourage everyone to go take a look at this repository. We'll have today's example on there as well, but I'm going to pull from this repo. So I'll select it. And then you just need to enter some more references so that we can be aware of what branch we want to pull from, as well as define the path for our model. In this case, we want to pull from a template model using our PyTorch example. This will take just a few moments, but what we'll end up with is all of the artifacts that we need now to test our model and ultimately deploy it. So it's going to include a serialized artifact of our inference model, right? This is a pre-trained model that we've trained just on a local system using Jupyter Notebooks. Also a custom .py file, which essentially contains, specific hooks for pre or post processing around our serialized model. Here, we don't have anything too sophisticated, so we are leveraging a bit of a generic setup, but you can go in and define specific hooks for more complex configurations. One thing that I want to highlight, and I'm just going to grab this file from my local system, is the ability to also define specific requirements, right? In the case of the model that we've trained, we're using Torch 1.8.0, but let's say we have other dependencies that we needed to include, or we're using different versions. So to reconfigure the environment, the base environment that's going to host this model, it's as simple as defining your requirement.txt file. We'll review the underlying environment and see whether those dependencies are already defined. If they aren't defined, then we'll encourage you to build a new environment. But what this does is it really abstracts away the requirement to understand in detail how to utilize Docker container or dependency management. And it makes it much simpler to have that scalable and repeatable process to getting these models in production. As I said, this was just to kind of highlight the functionality. We're using Torch 1.8.0, so I'm just going to remove this guy. Okay, so the next thing that I want to show you is how we actually test these models before production. It's a really neat framework to, provide extra confidence pre-deployment of your custom model. So this is going to be a pretty robust testing framework, a suite of tests that are somewhat customizable, but it's going to start with defining a prediction test data set. So I'm going to pull in a data set that I have configured and added to the AI catalog, which is our data management system. I'll select this data set, right? And then I can also define, some additional settings for testing this model. We are testing within a Kubernetes framework, so I want to allocate some additional, maybe less memory or maybe more memory for our specific pods. And the number of replicas you can define up or, set to a level that makes sense for your use case. So this is going to kind of imitate what you would eventually set up in production. And then we have a variety of tests. You can turn any one of these tests on or off, or configure some of the settings, as we'll see. The tests kind of increase in their sophistication and complexity. The first one is relatively basic, one that hopefully everyone has already checked on their model, but quite a common issue that we see in the wild is the ability for your model to actually handle missing data. So what we do is we run a imputation check to make sure that your model can successfully handle kind of unseen data or missing data. The next few checks are more around the stability of your model. So the side effects check is going to assess the ability to make batch predictions against row-wise predictions and verify that the predictions are returning the same values. We have a prediction verification test, which is a common framework that we see when maybe migrating models between MLOps clusters, where you already know and have a defined output, but you want to check that the maybe new versions of a model or maybe you've upgraded dependencies. You want to check that the latest model is within the boundaries of what you would expect. So you can define an output data set with an output column, and then you can define key matching thresholds with a passing rate. You can also define a couple more targeted checks around performance and stability. So here we have a performance check that's going to measure the resources spent making a prediction request, calculating it, and returning that prediction response itself. So here you can set, the response time limit if you have specific limits in mind. You can set the overall limit of the check itself. In some cases, this could run for, maybe longer than 10 minutes. And if you want to further kind of stress the system, you can increase the number of parallel users making those requests. This is, of course, much more realistic for real-time deployments. And then finally, we have the stability check, which is, kind of a close cousin of the performance check, but it's testing, with more flexibility around the prediction responses, where you can configure the payload sizes, as well as the number of users, and a little more flexibility around the duration and passing rate. So for our check, just to save time, running this full suite would probably take 15 to 20 minutes. I'm going to run a slimmed version of this check, and we'll circle back to it. I also want to add training data. And so this is going to be a foundation for providing a baseline for data drift, for accuracy drift. If done manually, sometimes can cause it's going to just take more time, but Datarobot has a pretty straightforward way to assign this. So here we want to use, okay. And now while this is loading, I was able to run the same model with the full suite of tests earlier this morning. So let's jump over to that model. And we'll just kind of run through the completed tests to give you a sense of what these tests are actually doing. So the first test that I'll show you kind of highlights a full pass across the full suite of tests. So you can see that we were able to kind of table stakes. We were able to get our custom model image up and running, and it was able to return a prediction. Next, we're going through more of the sophisticated tests that we just reviewed, our prediction error test, null imputation, side effects, and performance instability. And so some of these tests are going to have additional metadata that you can go in and review, like the performance checks, where you can get an assessment of across the different payload sizes, the average response time. Or you can actually go in and review, a full log of the output tests. So this is going to be much more detailed, but provide you those, perhaps important information to go back and see, okay, what was my test configured on? What was I actually executing to then make that, repeatable if you needed to replicate those results. So this test, it didn't fail, but we had a warning, and the warning came in our performance test, right? And essentially what happened was this took longer than the allotted time. So we defined 10 minutes to execute this test, and the test essentially timed out. So within each test, you can configure whether it spits off a warning or whether it's a hard fail. And in this case, we define it to be a warning. But again, you can go in and review the logs and see in more detail what was the cause of the warning, what was going on behind the scenes. So you have the output of the successful tests as well as output around any failures or any warnings. And you can see we're looking at the same model. We have the PTH file from our PyTorch, and we have our model artifacts here. So let's jump back to our model now, and we can test out our tests that we've executed so far. As I said, we wanted to speed this up, so this test only took about a minute, but that's because we skipped over some of the other longer tests. But it did pass, so we know that we're able to start up our image, and we're able to return some predictions. So the next step would then be to deploy our model. In this case, the deployment experience here is going to do two things. One, configure where we want to deploy our model to, right? What is the prediction environment that we want to host our model? And two, let's get this model configured for data drift and accuracy and overall kind of monitoring for the deployment. So the first thing is we're going to be deploying this to a Datarobot hosted prediction server, right? This is essentially a prediction server that we maintain. And when we make predictions, we'll make predictions against a RESTful API that we'll create from this deployment process. Here, we'll go through and start to define some of the model monitoring configurations. So we want to enable data drift, accuracy tracking, challenger analysis, and segmented analysis, where you're able to partition the monitoring results by specific segments. We see that we have learning data also attached. That's what we did previously. If we had a learning model, we would also be able to define retraining data. We'll stick a pin in this and we can circle back to this in a few minutes. But it's the ability to retrain at a periodic basis a model hosted within MLOps. Okay, so you can see now we kind of have our flight checklist at the top, where we have everything configured, ready for deployment. So the last thing that we'll do is name our deployment. And I'll just double check that everything looks good, and we are good to go. So I'll create this deployment. Here is a glimpse into some of our governance framework. We have workflows that can define specific paths to production. This being kind of an entry point where you have a definition of deployment importance, which aligns to how the use case is being utilized by the business. In our case, let's just say it's low importance, but it can go up to critical, and maybe those critical deployments have different requirements for pre-production review. So some of the deployment creation process here is accelerated because we already tested our model. So we've validated the custom model stability. We've already built our custom model image, and we attached our training data, right? So we've already established our drift baseline. So the only thing left is to create the underlying architecture for the deployment to return that REST API endpoint. So this will just take probably about another 20 or 30 seconds. Once the deployment is up, we'll highlight a couple of things. So the end goal is going to be to make some predictions. And so I'll show you how you can actually enrich the prediction of this custom model with prediction explanations. And we'll go through some of the other deployment options. The first path that we're doing is, making this deployment available with the REST API, but we have the ability to also deploy our model using what we call a portable prediction server. Essentially, you can deploy the model as a Docker container, so you can plug and play into resources beyond just those that we maintain. And we'll discuss some of our real-time and batch prediction process. Great, so here we are now inside our deployment. And it's going to be pretty bare because it's a new deployment. But I'm going to skip ahead. I'll come back to some of these more exciting model monitoring capabilities when I switch to one of our deployments that we've had up for a couple weeks, because it has a bit more exciting information. But here, what I want to show you basically is how to make predictions against our new deployment. So there's a few ways and a few paths, and I'll run through each, and then I'll stop and make predictions using our prediction API. The first path is quite easy. It's using this user interface to make batch predictions. So these are one-off batch scoring jobs utilizing Datarobot's batch prediction API, which has the ability to make concurrent, scoring jobs in, a very scalable way to easily make predictions. You can also now make batch predictions using a prediction job. So you can define the data source and types, and eventually, if you wanted to run this job automatically on a schedule, maybe you're running a predefined model weekly or daily or monthly, whatever the periodicity might be, you can now set that up where, it's, a little bit of configuration up front, but then the job is executed at the periodicity that you've defined. We teased this one a bit. So this is the ability to create a portable prediction server, essentially containerize our deployment. So we have our PyTorch model. Let's say we wanted to plug this into Azure ML or some other cloud provider. It'd be quite easy to do. You essentially download this as a portable prediction server, and you're able to launch and execute the container natively, maybe on local systems, or in a resource compute that you've defined. What's super exciting about this approach is, regardless of where you ultimately execute this this container, we have it pre-configured for monitoring, right? Using that agent-first approach that we kind of highlighted at the beginning. You would be able to make predictions wherever you want to manage the computer resources, but you would have Datarobot be the host for things like data drift, accuracy, and even challenger models, right? Where Datarobot still is adding value to the machine learning process significantly by automating some of the very often tedious, but very important tasks like model monitoring and model management capability. We also provide a variety of integrations out of the box. If you wanted to, integrate prediction right back to a Snowflake repository, you can configure that. Same with, a SQL server. And then the last tab here highlights, ways to make predictions using the prediction API. So if you wanted to make a batch prediction call, maybe you have a very large data set, you can do so here by toggling to the prediction type, whatever interface you're more comfortable with, command line interface, the API client. Maybe you just want to grab this to a clipboard and save the Python code, or using an HTTP. For this example, what I want to show you is using our real-time. And I'm just going to grab the deployment ID because I already have copied this script over here. So I'm going to grab in the new deployment ID, which you can see is also accessible up here. Right, and I'll save this shell, and then I'm going to make some predictions. Let me grab my iTerm. Great. So here, what I've actually done is told Datarobot that I not only want to make predictions, but I also want to return additional parameters in my prediction header. Right? Specifically, what I want to do is enrich my predictions that I'm returning from my PyTorch model with prediction explanations. Right? So this is going to give you configuration to the maximum explanation that you provide, threshold for high, threshold for low, using the Datarobot exempt prediction process. And now you can see those predictions have returned, and we can go back and say, okay, well, we have some other metadata in our prediction request. We have our feature strengths, right? Again, the prediction explanations now included with the prediction request itself in the row ID. So we made about 1,000 predictions just for the sake of this demonstration. Again, using the real-time process. So to change gears a bit, and so you can see our service health has picked up that the prediction requests were successful. that we were able to return those 894 predictions. And within the predictions, I kind of made the predictions quite bad. So we would see some example of data drift. Just refresh this page. So here we're surfacing data drift, which is essentially feature drift. So you plot by feature importance on the horizontal, and drift as defined by default population stability index. And what that does is it sets up this kind of quadrant view where you have high importance and drift features in quadrant 4. You can see that in this case, a feature called tax was significant as it was important to our underlying model as defined by permutation importance of 0.712. Over here in quadrant 3, you have additional features that have drifted. They're beyond our drift threshold that's set here around 0.2 for PSI, but they aren't red, right? Because these features have a low feature importance. And then we have other features that are below our feature threshold and across both feature boundaries for, importance thresholds, but below the tolerance set for feature drift. And so if I wanted to jump in and actually set up notifications, you can do so here. So if you wanted to be notified in real time when there's data decay or potential issues, that's something that we provide. You can use our out-of-the-box system for alerts, or you can configure third-party systems with webhook notifications to go into things like Slack or Teams or PagerDuty. And then you can also define, the specific thresholds that you want to set for the status of each of our monitoring dimensions. So what I want to do is jump back to a model that we've had in production for some time, right? And we'll just run through some of the other capabilities that are configured, things like challenger models and humility. So in this case, we actually have a model that had accuracy configured, meaning that we have both defined an association ID to associate prediction data to training, right? As well as having the outcome data available for the specific use case to surface. So the outcome data, depending on use case, isn't always available, or it varies pretty significantly by use case. But in this case, we do have outcome data that we can channel back to the system, and it's going to provide, an assessment of accuracy then, both by reviewing the model predictions and assessing and comparing those to actual outcome data that we know has occurred. So pretty related to providing, accuracy over time is our notion of challenger models, right? And challenger models in this framework are really shadow deployments. So we still have one champion model that's seeing live production traffic. But what you're able to do through this framework is attach a basket or a portfolio of models to that champion model to assess over time. And what we do to assess those challenger models over time is intelligently replay the prediction traffic against our alternative models. In this case, we have 3 alternative models to our Python model for loan default. We have a reference model We have an XGBoost model, and then we have a more sophisticated maximum accuracy model. In this case, these models are created automatically by Datarobot, but that need not be the case. You can see we have a custom inference as a champion. You can also have a custom inference as a challenger, or you can have those external models that we mentioned, where maybe they're running on some other system for compute. You can tie those in and have those as challengers too. So going across, you'll be able to see and compare prediction traffic across your challenger portfolio. You'll be able to compare accuracy across time, by varying, different error metrics, accuracy metrics. In our case, I think we had log loss shown, but maybe we wanted to surface KS. So we can do that. And then, an additional stability check might be how robust are our models to potential errors. So you can see some models are more robust than others to different server errors or data errors. And so where we're going with this framework is the ability to not just assess the quality of challenger models over time, but automatically build and trigger challenger models to join your portfolio. And challenger models are loosely defined, right? They can be anything. They can be models that maybe are different derivations of your champion model that have been retrained on newer data, and you can trigger those retraining jobs automatically. Perhaps it's, same specification, trained on a different feature list, newer data, you can slice and dice that in many ways. It doesn't need to be as drastic as a totally different framework or a different methodology. It can be a bit nuanced, which actually is kind of what we see more in production anyway. And then the last thing to highlight is our humility framework, right? So this is an interesting kind of governance guardrail that we provide where you can define essentially business rules on top of your deployment. And the rules can be set to different triggers. So you can have triggers around the prediction output itself, right? To maybe check and assess for anomalous prediction outputs. Maybe you want to check for large large outliers in our input data set for different features. So you can do that here by assessing numeric features. You can assess for low observation regions with categorical features as well. But if we play this across, right, for uncertain predictions, you would set your boundary for expectations, and then you can set an action. Right, and the action can be as simple as do nothing but track when this rule is triggered, or a bit more drastic as override the prediction with a known, maybe conservative response, or as severe as throw a 480 error that's returned with the prediction request. So we have two humility rules assigned to this deployment now, one for uncertain predictions and another for unlikely income, which is a feature input to our model. And we can see when and how often these rules are triggered over time. So that might influence tweaks or tunes to those specific rules. So a quick recap, what we did today. We took our PyTorch model, we registered it through our custom model workshop. We tested the deployment, right, to make sure that it was going to be stable before we go through the hard work of deploying the model and finding a potential error. But we use the testing framework that's provided through the model registry to do that. We then deployed our model with the artifacts that we pulled in from our GitHub repository for code management. Once deployed, we made predictions against our deployment, right? Using one of our many prediction options, in our case, prediction API. This model was then added to the overall deployment inventory that I have access to, right? In this case, I have 197 active deployments, 40 million predictions in the last 7 days. It was 196 before today, so that additional deployment is now included in my portfolio where it's tracked and assessed for quality over time using Datarobot model monitoring and management capability. So with that, I want to jump back over to our slide deck and kind of open up for general Q&A. So Chris and I are happy to run through any questions that the audience might have.
Yeah, I'm starting to see some pop into the chat here. So let's take a look at these. All right, so first question I see here is highlight on A/B testing. I think what we've seen so far is on the A/B testing front is it's mostly scripted outside of our prediction servers now. So what you've done, what Seth just walked through was that single model through to a sort of a stable Datarobot prediction server URL. We have seen clients do that with several models and then script predictions across them. It is a request we get a lot though, so we'll probably start to see us, take more ownership of that application. But right now it is more of a scripted piece of work. So next one here, Dev, QA, and Prod. Yeah, so this is certainly important for many of our clients. On our SaaS, you can actually provision multiple clusters of prediction servers. And I think Seth touched on it briefly, but we have a concept of a prediction environment, which lets us define both internal and external environments, what those environments are used for. So if you have like those sort of segregated dev, QA, prod needs, you would define those levels of prediction. And you can deploy models to one or more of those at a time and start to see how they perform in different environments and transition them across them throughout our overall governance and approval flow. So that's something we certainly support there. I don't know, Seth, I don't know that I understand the next question on feedback from deployed models. Is this feedback for on the monitoring aspect of it, or?
Yeah, maybe Itai. Sorry if that's not how you pronounce your name, but if you could add some additional detail, that'd be helpful. We can address it.
Okay, well, we'll wait for Itai. So. Yeah, this one's actually a good point. So I think Seth touched on it a little bit, but the core flow of this demo was very much showing how we take custom code and bring this into the application and deploy it and host it on our own servers. But a big portion of what we also focus on is monitoring and management of models running outside of the Datarobot platform. When we talk to large organizations, it's not uncommon for them to have different teams using different technologies for both training and deploying models. So we've borrowed sort of a standard DevOps concept of an agent to actually get monitoring on these remote models. So an agent can be installed at or near wherever this model is running. And I think, Seth, you mentioned this is open source models, models running on distributed compute, actual Datarobot models running outside of the system. And using our MLOps library, wrap that of code to report predictions, features, and performance metrics back to MLOps and get that same level of standardized monitoring within the tool. And I think one thing we're super excited about as well is sort of pushing this agent concept forward. And actually in our release next week, we're releasing a second agent, which we're calling the management agent, which is going to be more about managing the deployment lifecycle of a remote model, but still getting that same level of integration back into MLOps, where it's a very easy one-click deployment, and have this management agent then take up the task of preparing the environment, deploying the model, setting up our monitoring so we get that feedback into things like our accuracy drift challenger framework. So that's another area we're super excited about, and I'd recommend checking out our release next week. Going down. Oh, looks like Steph, you already answered that one. I was going to call out our Datarobot user model repo. So good call there. So do we have the possibility to change serving environment for build and prod? Definitely. So those prediction environments, they don't have to be sort of the same underlying infrastructure. You can very easily, for example, a client using our SaaS might be able to develop a model on SaaS, deploy it to a Datarobot prediction server, test it out really quickly, have that be sort of the dev validation. And then using our agent concept, deploy that to a production infrastructure, whether that's like a Kubernetes, a Spark, on-premise. And again, that's sort of what we're trying to accomplish with our management agent coming out shortly. So I'm just catching up on what I wrote here. I see. So this is about, passing back data. Touched a little bit on our retraining policies, but the concept there is that we sort of have a framework here with drift accuracy at the Challenger framework, where we're hoping to start introducing some capability for both retraining and even more automated retraining. And along with the concept, we allow you to attach additional data sets to a deployment that could work as a retraining data set. From there, there's retraining policies, and we sort of look at those as in sort of two different aspects. So a more traditional retraining policy where you might trigger a retraining run of the same model, same configuration, just on a new data set, based on something like a drift or accuracy detection. Or perhaps just, the data is changing frequently, so you just have something scheduled. So that would be a way to incorporate a new retraining data set, bring it into the Challenger flow, and go through that into production. On the retraining side, we're also looking at using our DNA as an AutoML company and suggesting training policies that almost take a step back, leverage the full Datarobot platform to always be exploring, other modeling techniques, bringing those in and see if taking a sort of a higher level look at all the modeling techniques possible could introduce higher performance models into production. So we don't have an open source environment. You can, I think what Steph mentioned earlier, Drum is for at least the custom model side here, but we do have a trial that you can apply for, and I think it's a 2-week trial where you can play with most of everything we've shown here today. Next question.
Well, Chris catches up on the threads. Yeah, the trial, just go to datarobot.com and you'll be able to request a free trial for the application. Both AutoML and MLOps are included there.
Okay, I see one more popped in here. On the Snowflake side, the Snowflake actually has a big summit today, which we're actually at as well. Luckily, that one's pre-recorded. But yeah, as I think over the last 6 or 9 months or so, I'd say we've really doubled down on our partnership with Snowflake. We're just seeing like a very high increase in clients of ours that are also starting to leverage Snowflake as their primary database. So if you think about what we showed today, that prediction API that Seth showed, how that usually works with databases is we pull data over JDBC, we score it against those prediction servers. Our batch predictions sort of scale up to you have on your server, and then we write that back over JDBC. With databases like Snowflake, JDBC is not always the optimal way of doing that. So we've taken a look and implemented a few somewhat cloud database specific, and then some for more specifically to Snowflake for handling deployment and predictions. The first being, and this is the more cloud database centric one, is that batch prediction API that Seth showed. We recently introduced a connector that's leverages more cloud database functionality to quickly dump data to object storage, score it there, and then bulk import it back using those specific cloud database commands instead of just pure JDBC, which helps us a ton in speeding up the extract and load process. And then what you'll actually see at the summit today, and this one is very specific to Snowflake, what they're announcing is a concept of Java functions. And when we heard about that through our partnership, it was almost easy to see a very natural fit with one of our other deployment methods, which we call Java scoring code. And that's the option to just download a Datarobot model as a jar and score that wherever you might need it. So Spark is a popular option there. With Snowflake, it was a very natural fit to now offer the ability to drop our models directly into Snowflake, skip everything about extracting data out of that database, and then also leverage their ability to boost their warehouses up and go massively parallel during your predictions to increase scoring speed there. So that's a lot of what we're showing at the summit today. I think we have a minute or so left. I think the last question, I think I touched on that a bit with our retraining strategy there that I mentioned is our approach there. I haven't actually been checking the Q&A tab if anything's in there.
So one more question.
You want to take that?
Yeah, one question just popped in around the pickle. That's similar to what we did today. So we had the PTH file because we were looking at a PyTorch, but if it was a different, maybe an XGBoost or a scikit-learn, it would have a pickle file, and you would go through the same structure that we did. So the what we call the custom model framework, where you're able to provide the inference models that you've built and test and deploy those using MLOps. It's quite flexible, where you can bring in models from a variety of different sources, right? Again, whether it's Python or any open source and some closed source as well. Well, happy to, if there's other questions, you can reach out to me or Chris directly. We're happy to connect, look for us on LinkedIn or other places, or if you want to reach out to Datarobot, you can go to the website, check out the trial, or you can submit questions directly if you want to get other access. But we're happy to chat and encourage you to check out the open source repository, where you'll have access to kind of a slim version of what we ran through today using the Datarobot user models and validating and testing those pre-production and even hosting them through a web service. So awesome. Thanks for joining us today. We really appreciate the time. Hopefully you found it useful and interesting. We're happy to, again, answer any questions that might come up. Thanks again. Enjoy the rest of your time at MLOps World, and thanks for MLOps World for helping us with today's demo. Thanks.
Great. Thanks. Have a good one, guys.